with solving the systems using substitution and elimination. Now you know how to do this. This is really easy. Problem number one, we're going to go through and do all the substitution ones first, so we're not switching back and forth. So we're going to do these by substitution. Now, do you remember what that means? That means get a variable by itself. And if you're smart about it, you will choose the variable that's already by itself, right? Like, see this x right here? There's nothing hooked to it. Even this y has a negative. I would pick that x right there to get by itself. If you get something else by itself, you're probably going to have fractions. So let's get this x by itself. So x equals 4 minus 2y. So just get a letter by itself. Then you take whatever that letter equals and substitute it in for that letter. So in the top equation, I got the x by itself. Then I'm going to take that and plug it in right here. So 4 minus 2y minus y equals 3. You guys have done this before. Huh?
Isn't it like, it's like the chapter where it's like substitution and there's like two other types of problems?
This is substitution. Yep, here we go. And in a minute we're going to do one of the other ways, which is elimination. And then in this chapter we're going to actually learn a couple of other ways that you don't know yet. But we're starting with what you do know. So we'll do the distributive. So 8 minus 4y minus y equals 3. Then we can combine our y's. So 8 minus 5y equals 3. Then we'll subtract the 8. So negative 5y equals negative 5. And it looks like y equals 1. But remember, that is not the end of the problem. Now we have to go back and plug the 1 in. And you can plug it in here or here. I like to plug it in here. Because if I put 1 in there, it looks like x is going to equal 4 minus 2, which is 2. Yeah. And then I write my answer as 2 comma 1. These are lines. If you were to graph these, they would be 2 lines. And the answer you get is the point where they cross each other. So that's why we write it as a point. Okay? All right, so the next substitution, I'm doing only the substitutions. The next one is x plus y squared equals 5, and y equals x plus 1. Now, in this particular problem, you already have a letter by itself, right? So you don't have to do anything. You're just going to take that and plug it in right there. So we have x plus 1 squared equals 5. Now, you know what to do with that. How do we handle x plus 1 squared? Distribute. It's a foil, a foil, a foil, a foil, a foil, okay? We're going to foil it out. So we have x plus x squared. Okay, if it helps you, go ahead and write it twice so you can see it. Now, some of you don't need to do that, but some of you do, and it's okay. That means x plus 1 times x plus 1. So it's going to be x squared plus x plus 1 equals 5. So I have my x out in front, and then I have all this foiled out, and it equals 5. Everybody good with that? So let's clean it up a little bit. So we have an x squared. Then it looks like we have 3 x's plus 1 equals 5. What do I do with that? Move the 5 over. This is quadratic, so I want to get a 0, right? And then after I move the 5 over, minus 5 from both sides, I heard somebody say, can't you factor it? And you can. Now, what if you don't want to factor it? What else could you do? Quadratic formula, yeah. somehow you gotta solve it. So it does factor x, what? How does that factor?
X plus 4, x minus
Plus 4 minus 1?
So then when you said equal to 0, is it
And
negative?
you set it equal to 0 and solve. So x, I'm gonna get two x values, right? I'm gonna get x equals -4 or x equals 1. Now you're not done though. Just like before, you're gonna have well this time you're gonna have two ordered pairs. The x's are -4 and 1, but you still need to figure out the y's. So if x is 1, it looks like y will be 2, right? If x is 1. And if x is -4, y would be -3. So what that means this time is, that's a parabola. Squares are parabolas. Remember your squaring function? That's a parabola. And this is a line. So we have a parabola and a line. Does it make sense that we get two places where they cross each other? Yeah. Yeah, that makes sense. All right, one more substitution one, and then I'll shut up, okay? Number 6. X minus y equals 4, and 2y minus 2x equals 3.
You can just do like y equals 4, or you could do -y equals 4 minus x, right?
I could, but I
Or
don't
you could do
want
like x equals 4
that
plus
makes
y.
more sense.
Yeah.
You could do the other, but then you have to deal with the negative. So it's just easier to add the 4 to the other side. So just say x equals 4 plus y. Does that make sense? Then I'm going to take that 4 plus y and put it in for x. Remember, you're substituting it in for x. So 2y minus 2 times 4 plus y equals 3. What's the matter, Cammy? Why are you making a face?
Don't you get a number equal to number?
I don't know. Let's see. So 2y minus 8 minus 2y equals 3. Don't forget to distribute your negative here, right? Oh, now I see what Cammy was talking about. These cancel, don't they?
Yeah.
So I'm left with -8 equal to 3? So what? No solution. No solution. -8 does not equal 3. Even in some of you guys' math, -8 does not equal 3, right? No, 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 no. What does that mean is happening? That means we have two lines and they don't cross each other. They're parallel.
I'll pull you back.
They are parallel.
Like, it's 6 bucks.
They're
What's here?
They're parallel.
7 or 6, yeah.